Alright, the inverse of a function reverses the coordinates of the ordered pairs. Graphically, the inverse relation is the reflection of the function in the y equals x. So y equals x, think it as a mirror, okay? Then whatever you have, so it's going to be reflected over the y equals x line. Think it that way. So, and let's say you have a point 1 and 2 on f of x. On the inverse function, you will have 2 and 1. Okay, so the coordinates x and y coordinates switches. Okay, so a systematic method for determining the equation of an inverse of a function. So first what you do, write the equation in y equals form. Let's say if you have f of x equals x squared plus 5, then you're going to write it, replace f of x by y and write it as y equals x squared plus 5. Next step, interchange x and y in the equation. So wherever you see x, replace it with y, and when you see y, replace it with x. Then solve the new equation for y, okay? And if that equation is a function, if that is a function, then replace y with f inverse notation. So the f inverse notation, you see it as f to the power of negative 1x. Okay? It's like, you will see it like that, but it doesn't mean that you are taking the power of negative 1. It just, that is how it looks like, okay? The inverse function. Let's look at example 1. For each of the following functions, f of x, state the domain and range of f of x. State the domain and range of the inverse of f of x. Graph f of x and use it to graph the inverse. State whether the inverse is function. Determine the inverse of the function algebraically. Okay, so let's start with I. Okay, state the domain and range of the f of x. So this is a parabola, correct? Actually, it would be just easier if we sketch it first and then write domain and range. So let's sketch f of x. So this is a parabola. The vertex is located at negative 1 and negative 4. Negative 1 and negative 4. This parabola opens up. And the a value is 2. So step pattern 1, 3, 5 will be multiplied by 2. So you get 2, 6, 10 for the step pattern. Okay, so we have negative 1 and negative 4 here. Then we are going to go 1 right, 2 up. So we have 0 and negative 2. We go 1 left, 2 up. So negative 2 and negative 2. Okay, then we go 1 right, 6 up. 1, 2, 3, 4, 5, 6. 1 and 4. And we go 1 left, 6 up. So we get negative 3 and 4. Okay, next, let's write the domain of this function. It's a parabola, right? XCR is the domain. And the range, YER. So y values are going to be greater than or equal to negative 4. Okay, so the next question is state the domain and range of the inverse function. So when you're doing the inverse, actually domain of the original becomes range of the inverse, and domain of the range of the original becomes domain of the inverse. So I'm gonna use domain of original, so that will help me to write the range of the inverse. So I'll just of course switch x with y. as I do that. Okay, so now domain of the original becomes range of the inverse. Okay, and the range of the original becomes domain of the inverse. Okay, but again I'm gonna replace y by x this time. So we get x er x greater than or equal to -4. Okay, next question. Graph f of x. We already did. Now use it to graph the inverse. So what did we say? We are going to replace x and y coordinates. Okay, we interchange them and then put it on the graph. Okay, what do we have here? We have -1 and -4. Switch the coordinates. -4 and -1. So -4 and -1. Next, we have a point 0 and -2. So on the inverse, we are going to have -2 and 0. -2 and 0. Okay. Next, we have -2 and -2 on the original. Switch the coordinates. You still have -2 and -2. So you have 1 and 4 on the original. Switch the coordinates. You have 4 and 1. 4 and 1. And you have -3 and 4 on the original. Now you have 4 and -3. 4 and -3. There we go. So that is the inverse. Okay. Inverse of f of x, and this one was f of x. Next question. State whether the yes. Yeah, we are just going to answer that. State whether the inverse is a function. Is it a function? No, it's not a function, right? If you apply the vertical line test, it fails. So we say inverse is not a function. Okay, so next, determine the inverse of the function algebraically. Alright, so let's do that. First step, write the equation in terms of y, right? We're going to apply that. So replace f of x by y. That is the first step. Step 2, interchange x and y in the equation. So when you see y, replace it with x. When you see x, replace it with y. Next step, solve the new equation for y. So we're going to solve this for y. How are we going to do that? Okay, so first move -4 to the other side. You get x plus 4. So you are trying to isolate this bracket, okay? This y plus 1 square first. So therefore get rid of that 2. So this y plus 1 square is multiplied by 2. So divide both sides by 2. So we have here then y plus 1 square equals x plus 4 over 2. Now take the square root of both sides. So you get y plus 1 equals, now you take the square root, you get plus and minus, right? X plus 4 over 2. And finally, move the 1 to the right. Y equals -1 plus and minus square root of x plus 4 over 2. You could also write it as -1 plus and minus 1 over 2x plus 2. That would be okay too. You can see, okay. So that is the equation. So so let's look at step 4. What does it say? Replace y with inverse notation if the inverse is a function. But we already see that it is not a function. So therefore, I'm not going to replace y by inverse notation here. Okay? Let's look at the next question. We have f of x equals 1 over x over 2. Again, we are going to answer the same questions. Okay? So we can sketch this first. So there's a rational function. There's a horizontal shift 2 units to right. Okay. So we have x equals 2 as a vertical asymptote. And there is no vertical shift. So we still have a horizontal asymptote at y equals 0. Okay. So let's take 2 points from the parent function. I'm going to take 1 and 1, negative 1 and negative 1. So only there is a horizontal shift, right? D value here, positive 2. So you get x plus 4 and y. Oh, you can't? Oops, sorry. Okay, so we are taking those 2 points, and the mapping rule is going to be here, x plus 4 and y. 2 to x plus 2. Why did I get 4? X plus 2. Okay, because there is only d value. Alright, now add 2 to x coordinates. Keep the y coordinates as they are. Okay, so 3 and 1. And the other one is 1 and negative 1. 1 and negative 1. Oops. Okay, let's answer the questions. State the domain and range of the original. Domain XER, and we have to exclude the vertical asymptote. So x cannot be 2. Range YER, horizontal asymptote at y equals 0. So y cannot be 0. Now we are going to state the domain and range of the inverse. So we are going to do same as part A. Okay? So domain of the original becomes range of the inverse. I'll just change x by y. So I get YER. Y can't be 2. Okay? And the range of the original becomes domain of the inverse. So replace just y by x. So you get XER. X cannot be 0. So part 3, graph f of x, we already did. And use it to graph the inverse. Okay, so like we are going to do like the previous one, okay, but now we have asymptotes here. What are we going to do with the asymptotes? So yeah, exactly. So y equals 0 becomes x equals 0. X equals 0. X equals 2 becomes y equals 2. Okay. Now let's take the points. 3, 1 becomes 1, 3. The other point was 1 and negative 1, that becomes negative 1 and 1. Negative 1 and 1. Next step, state whether the inverse is a function. Is it a function? It is, right? It's a function. It's another rational function. So it is a function, the inverse. Next step, determine the inverse of the function algebraically. Okay, let's start. So we replace f of x by y. Then we interchange the x and y. So replace y by x, xy by y. How are you going to solve for y here? You can do cross multiplication. Okay. So x times y minus 2 becomes 1 time equals 1 times 1. Okay, now I'm trying to isolate y, so I need to isolate y minus 2, that bracket, that factor. So I'm going to divide both sides by x, and finally move negative 2 to the right, so 1 over x plus 2. Okay. Next, if it is a function, you replace y by the inverse notation. So now we already said that it's a function, so we can replace y by f inverse notation. You can't see, maybe I'll just move. Is it good? Any question? No? Okay. Moving on. Next, example 3. Given the function g of x, negative 2x plus 3, find g inverse of 3 minus 2 times g of 3 over g of 2 square plus g inverse of 7. So it's kind of complicated, right? It looks scary, but it's not. Let's look at it. So first, looks like, we need to find g inverse function anyhow to be able to calculate those. So let's find g inverse for this one. Okay? So replace g of x by y. That's the first step. Then substitute x for y, y for x. Step 2. And isolate y from here. So you get, I can move negative 2y here. So 2y equals negative x plus 3. I moved negative 2y to the left, x to the right. Okay, finally, divide both sides by 2. Or we can just, divide the whole thing. Alright. Is this a function? What kind of function is this? It's linear, right? It is like it's the same as negative 1 over 2x plus 3 over 2. So it's a linear function. Then we can replace y by the inverse notation. So g inverse of x equals, so whichever you find easier. I think this is going to be easier to calculate. So I'm just going to keep the other one. But doesn't matter. Both are okay. Okay, so what do we need to know to calculate this? So we need to find g inverse of 3. Okay, first calculate those separately and then put them all together. Otherwise, it's going to get confusing. Okay, so we need to find G inverse of 3. Yes? Simplify this one? No, you can't. How are you going to simplify? Yeah, no. What are we going to do though? Don't do all the calculations in this. Okay, so do them separately. First calculate G inverse of 3, then calculate G of 3, then calculate G of 2, then calculate G inverse of 7, then put them all together. Okay, that's much easier. Yeah, so we cannot this one cannot be simplified. G inverse of 3, let's calculate that. Okay, so substitute 3 in the G inverse. What do you get? Negative 3 plus 3 over 2, 0. Correct? Okay, next. G of 3. You can multiply by 2 later on. First calculate G of 3. That's what you need, right? G of 3. So substitute 3 in the G function. Negative 2 times 3, negative 6, plus 3, negative 3. Okay, next. What do I need? I need G of 2. G of 2. Substitute 2. Negative 2 times 2, negative 4. Plus 3, negative 1. Okay. Next. G inverse of 7. G inverse of 7. So substitute 7 in the inverse function. Okay. So negative 7 plus 3, negative 4, divided by 2, negative 2. Now we're going to take those values and put it all together. So in numerator, what do we have? G inverse of 3, we got that being 0, minus 2 times G of 3, so 2 times G of 3 is negative 3, over G of 2 square, G of 2 is negative 1, square it, G inverse of 7, negative 2. Let's simplify. So you have 6 over negative 1, so you end up with negative 1. Okay, so next example. Given the function f of x equals 2 over negative 3x plus 5, find f inverse of negative 2 and 0. Okay, let's follow the steps. Replace f of x by y. Substitute x for y, y for x. Now we're going to solve for y. Again, we're going to do cross multiplication. So that gives us x times negative 3y plus 5 and 1 times 2. Divide both sides by x. Move 5 to right. And then finally divide both sides by negative 3. So divide everything by negative 3. So you get y equals negative 2 over 3x plus 5 over 3. Correct? Now substitute. Is this a function? What kind of function is this? Rational function. So we can replace then y by the inverse notation. So f inverse of x equals negative 2 over 3x plus 5 over 3. Now substitute negative 2. So negative 2, 3 times negative 2 plus 5 over 3. So negative 2 and negative 2 is gone. So 1 over 3 plus 5 over 3, 6 over 3, which is 2. Okay, what happens when you substitute 0? You get 0 for denominator, which is undefined. So there is no such a point. Okay, you can't do that. So that's undefined. All right.